Have you ever just stared up at the night sky, maybe seen a tiny pinprick of light that you know is another galaxy, and thought, how on earth did we even figure out what that is? Because,
Hmm.
for most of human history, those were just little sparkly dots. Today, we're taking a deep dive into how we've actually managed to unravel some of the universe's biggest secrets. And it really all comes down to these incredible spacecraft and the way they've opened our eyes to the cosmos.
That's right. We've got some really fascinating resources here that explore everything from the fundamental principles of how we observe objects trillions of miles away to the sheer audacity, really, of launching something into the void and having it actually work. It's pretty remarkable when you stop and think about it.
Absolutely. And it all starts with seeing, doesn't it? I mean, our eyes are amazing, but they're a little, well, limited in what they can pick up from the vastness of space. That's where telescopes come in. Our source describes them brilliantly as light buckets. They're essentially collecting a lot more light than our eyes ever could, using mirrors or lenses to make distant objects appear much bigger, much clearer.
It's like cupping your hands around your ears to hear better.
Exactly. You're just gathering more of the signal.
And the power of some of these modern ground-based observatories is just astounding. The Keck telescopes in Hawaii, for example,
Hmm.
they are so incredibly sensitive. The source says they could, in theory, spot a single candle flame flickering on the surface of the moon.
Whoa, a candle
Mm,
on the moon.
yeah. Think about that for a second. That level of sensitivity lets us capture the faint light from the earliest galaxies, right after the Big Bang.
Wow, that really puts it in perspective.
Gives us crucial clues about the universe's origins.
But even with those huge telescopes on Earth, our atmosphere gets in the way, right? It sort of blurs the light.
It does. It adds a bit of cosmic static, as you said, blurs things.
So the obvious next step was to just get above it.
Exactly. Launch telescopes into orbit, escape the distorting effects of Earth's atmosphere.
For sharper images.
Much sharper, much clearer observations. And what's fascinating here is that different types of space telescopes study different parts of the light spectrum, not just visible light.
Right, like X-rays.
Precisely. X-rays come from really energetic stuff like black holes, neutron stars. So specialized telescopes let us study these violent cosmic processes.
Okay, so it's like we're tuning in to different cosmic radio stations.
That's a good way to put it. You've got telescopes for ultraviolet light, great for studying super hot young stars,
Uh-huh.
and then infrared telescopes. They can actually peer through those huge clouds of gas and dust where new stars are being born.
Oh, cool. Like night vision goggles for the universe.
Pretty much. Because stars are often born inside these dense clouds,
Yeah.
visible light can't get through, but infrared can.
So we get to see the very beginning of star formation.
Exactly. And the Hubble Space Telescope is, well, just the perfect example of a space-based observatory's power.
Oh, yeah. Hubble's images are iconic.
For over 2 decades now, breathtakingly clear images, countless discoveries, measuring the universe's expansion, seeing distant nebulae.
And it's huge, right? Like a bus.
About the size of a bus, yeah.
Oh.
Weighs around 11 tons, and astronauts have actually visited it
To fix it.
for repairs and upgrades multiple times, servicing something that complex in orbit.
Yeah.
It's a remarkable achievement in itself.
It really is. And it's a great reminder that what we see, visible light, the rainbow colors, that's just a tiny fraction of the information out there.
Just a sliver.
Our source mentions how white light is made of many colors.
Mhm.
And beyond red and violet, there's infrared, ultraviolet, invisible light.
It's like the universe is whispering secrets in all these different wavelengths.
And we needed special ears, these telescopes, to hear them.
That's a wonderful way to put it. And by studying light across the whole spectrum, we learn so much more temperature, composition, even how things are moving.
Okay, so we've built these incredible eyes, but then comes the maybe even more audacious part,
Right.
actually getting out there. Which brings us to the distances. Just mind-boggling. Our
Hmm.
source talks about light years, the distance light travels in a year. And light is fast.
Incredibly fast. Around the Earth 7 times in a second. To the moon and back in about a minute.
But space is just vast.
Immense. The scale implied by light years, even though light's the speed limit, it takes light from stars and galaxies millions, even billions of years to reach us.
So interstellar travel.
Yeah, that really highlights the limits of our current tech. Direct travel to even the nearest stars in a human lifetime. Just not feasible right now.
Right, so no warp drive just yet.
Not yet. But, as the source points out, spacecraft can reach planets and moons in our own solar system. They're much closer, our cosmic backyard, basically.
And we've been busy exploring it.
We certainly have. Missions to every single planet, landings on Venus, Mars, even Titan, Saturn's moon.
Wow, Titan 2.
Yep.
Yeah.
And visits to asteroids and comets. Like robotic ambassadors checking out the neighborhood.
That's amazing. But humans. We've only walked on the moon, right?
Yeah. That's correct. The moon is still the only place beyond Earth humans have set foot. 12 astronauts between
Ooh.
69 and 72.
And no one's been back since.
No one. It really underscores the immense challenges and costs of crewed missions beyond Earth orbit. There's ongoing debate about where we go next with humans.
It's still kind of astonishing. But we have sent a lot of robots to Mars.
Oh, definitely. More missions to Mars than any other planet, the source says. Orbiters circling, landers, and those amazing rovers.
Like Opportunity. That thing just kept going.
Incredible resilience. They trundle across the surface, controlled from Earth, sending back images, data, finding evidence of past water, even water ice.
Which gets you thinking about life, doesn't it?
Absolutely.
Mhm.
Past or present, it's the big question. And then you have the deep space probes like Voyager 1 and Pioneer 11.
They're actually leaving the solar system.
Voyager 1 definitely has. Pioneer 11 is on its way out, too. And Pioneer carries that plaque. Drawings of humans, info about Earth.
A message in a bottle for the cosmos.
Kinda, yeah. A hopeful gesture cast out into the void.
That's lovely. And speaking of getting things moving,
Mm-hmm.
that balloon rocket explanation, so simple but effective.
It really demonstrates thrust perfectly, doesn't it?
Yeah. Expel gas one way, rocket goes the other. Equal and opposite reaction.
Even works in a vacuum, where there's no air to push against, just expelling mass at high speed. That basic principle lifts these huge rockets.
Incredible. Okay, so getting there is one thing, but actually living up there.
That's
Space stations.
exactly. Long-term homes and labs for astronauts.
And the International Space Station, the ISS, that thing is massive.
Huge. Largest structure we've ever built in space. Took over 40 rocket and shuttle flights to assemble all the parts.
Wow.
A massive international collaboration, almost the size of a football pitch. You can actually see it from Earth sometimes.
Really, like a bright star moving.
Exactly. A bright moving light. Inside, you've got modules for living, working, sleeping, everything.
But life without gravity, that must be weird and challenging.
Oh, definitely. Floating sounds fun, but your muscles don't work hard. They get weak. Bone loss, too.
So they have to exercise like crazy.
Rigorously. Every single day. Our source mentions Valery Polyakov, a Russian cosmonaut.
He spent a record time up there.
Yeah, over a year. 438 days. Imagine the discipline to keep exercising for that long in 0G.
That's incredible. What about like daily stuff? Washing.
Tricky. They use damp cloths mostly to save water. Water is precious up there.
Makes sense. Food? Is it all just tubes of paste?
Not really anymore. Surprisingly varied menu, the source says. Often specially packaged, but quite a range.
Huh. And becoming an astronaut, that takes serious dedication.
Years of hard work. Math, science. You need a strong background. Potential commanders often need pilot training.
And they train in pools for spacewalks.
Yep. Huge swimming pools to simulate weightlessness. It's intense preparation.
And different jobs, too, right? Commander, specialists.
That's right. The commander pilots and leads. Mission specialists run experiments, do the spacewalks.
And they're all living in pretty tight quarters.
Requires serious teamwork. Getting along is crucial. It's a fascinating study in human dynamics, really.
High-stakes zero-G living. And here's a weird fact. Gravity squashes us during the day, so we're taller in the morning.
Slightly, yes. Gravity compresses your spine, something you don't experience in weightlessness.
Wild. Okay, let's hit some of those really cool spacecraft facts.
All right, let's do it. Some are truly mind-bending.
Okay, how about this? Astronauts on the ISS can take photos of the pyramids,
Uh-huh.
but from the moon, you can't see any human-made structures on Earth with the naked eye.
Puts things in perspective, doesn't it? Humbling.
Definitely. And spacesuits being white, not just fashion.
Nope. Practical. White reflects heat best. Crucial in direct sunlight in space. Plus, easy to spot against black space during spacewalks.
Safety first. Okay, what about space junk? Is that a real problem?
Oh, yes, a growing one. Hundreds of thousands of pieces, old satellites, rocket bits, even lost tools orbiting Earth at high speed.
Like a cosmic minefield.
It poses a real threat to active satellites and future missions. We're looking at ways to track it, maybe even clean it up.
Yikes. Okay, and crashing probes into planets. Galileo into Jupiter.
That was deliberate, yes. After its mission, they crashed it to avoid any chance of contaminating Jupiter's moons, like Europa with Earth microbes. It got crushed by the atmosphere.
A noble end. And gravity assist using planets like slingshots.
So clever. Using the gravity of the sun or planets to speed up spacecraft, change direction, saves fuel, cuts travel time massively. Celestial billiards.
Love that. Okay, flying to the moon in a 747, impossible, obviously needs air.
Right.
But if it could, at cruising speed, it would take nearly 18 days.
Almost 3 weeks. Shows you just how far away the moon actually is, even though it's our closest neighbor.
Never pack snacks.
Uh,
And aliens. Any confirmed landings?
Nope. Source confirms.
Huh.
No confirmed alien landings. Most UFO sightings have normal explanations. Sorry, sci-fi fan.
Okay. What about future stuff? Missions to the sun.
Yeah, the Parker Solar Probe is doing that right now, getting incredibly close, flying through the sun's outer atmosphere, studying it like never before, pushing the limits of heat resistance.
Wow. And rocket engines, the heat, space shuttle engines.
Around 6,000 degrees Fahrenheit, burning millions of pounds of fuel in minutes. Just immense controlled power to escape gravity.
Mind-boggling. And finally, those footprints on the moon.
They'll last for millions of years. No wind, no weather to erase them.
Okay.
Silent testament.
That's profound. And the source had that top 10 list, too.
Quick highlights, yeah.
Yeah.
Tallest rocket, Saturn V, fastest spacecraft, New Horizons zooming past Pluto, longest spacewalk record, most reused, shuttle Discovery, Voyager 1 being the most distant, just incredible achievements.
An amazing list. It really shows how far we've come.
Absolutely.
So wrapping up this deep dive,
Yeah.
we've seen how telescopes, these light buckets, are our eyes seeing across the spectrum. Spacecraft are our robotic explorers, reaching planets, even interstellar space,
Our robotic pioneers.
and living and working in space. It just highlights human ingenuity and adaptability against incredible challenges.
Definitely. From understanding the physics to building the tech, it's
Yeah.
a constant journey of discovery, pushing boundaries.
So when you think about the sheer scale of the universe and how fast our technology is advancing,
Yeah.
it makes you wonder what discoveries are still out there. What truly unimaginable things await us.
It's exciting to think about.
Maybe it's not just bigger telescopes or faster rockets. Maybe it's entirely new ways of, I don't know, perceiving the cosmos, traversing it.
That's a fascinating thought to end on. What might the next leap look like? A truly exciting prospect.